Hi, everyone. Thank you for being here. We're going to start on time. So I'm Niko, and I develop NextGraph. Today we're going to be building a local first, of course, a peer-to-peer and end-to-end encrypted social app. I will make a 10 minutes introduction to NextGraph because you might not know what it is, and then we will live code and also interact between each other because it's a social app, so I will need you to install the app and share contacts between each other, and then so we can test what we did. So it's the proof of concept we will do about web app that lets you rate your contacts. Like LinkedIn, you can rate the skills, your professional skills, in your social network. It means that there is no central database, but instead it's the people that you know that you will rate. And then you can query, send a query in the social network and get the results. So first of all, let's start with this introduction. So I worked on that for 3 years, NextGraph. It's funded by NLNet Foundation and the European Commission through the NGI Fund. What is NextGraph? It's a protocol, first of all, at the bottom, for end-to-end encryption, end-to-end encrypted sync of data, sync of CRDT operations. You will hear tomorrow about KeyHive and BELAY, which is a new protocol of this that is doing basically the same with differences. Today you're hearing about NextGraph. On top of that, NextGraph is a framework for developing collaborative application. And we want to build a full ecosystem on top of this framework of integrated apps. So it's a work in progress. The protocol is ready. The framework is being released this year. We will use it today. Unfortunately, the documentation is not published yet, so it's going to come very soon, but we have a beginning of an SDK. So that was, you didn't see any of the slides, right? No, so that was the second, the third, the fourth, the fifth, the seventh, and why another protocol? We were here. Why another framework and why another protocol, like if there were not enough of them already, right? So when we started in 22, we were the first to do this kind of end-to-end encrypted sync for CRDTs. What I call encrypted DAG, the DAG of operations. We believe that combining a sync protocol, that there are many, right? You heard before, you will hear tomorrow, there are many sync protocols for CRDTs, but to combine this with end-to-end encryption, it really radically changes the whole ecosystem and towards more private and resilient software. If you don't know about CRDTs, which I doubt, you can go to those two websites to read more about that. We believe that privacy is important, so I'm sure you agree. Once everything becomes local first and CRDT based, it's easy or almost easy to add end-to-end encryption to it. What else? Our protocol has been designed from the beginning to securely transport any kind of CRDT. So we have AutoMerge, YGS, the two most famous CRDTs out there, and we will add LoRa when we have a moment. We also have developed a CRDT for graph data, RDF, if you know about that. That will be the topic of the coding session after. So I hope you're not allergic to RDF, otherwise the door is here. But I will show you that it's easy to develop with RDF data. So we have done this CRDT especially for RDF. So those three CRDTs are combined into the framework. AutoMerge and YGS, they deal with JSON, rich text, Markdown, and plain text. With that, you can already do a lot of applications, right? And with RDF, you can do more. Then we also added the immutable binary files that you always need, right, for your assets and for images and things like that. They are immutable. You're not going to edit them in the system. So we use content addressing for that. And it's, of course, end-to-end encrypted too. And then we have this option to combine documents between each other, embed them, a bit like Notion is doing for note-taking, that you can combine different types of documents. So it's a framework, as I said, for developing apps. But our main ultimate goal is to build an integrated solution of malleable software, like to be able to compete with the solutions of big tech. So when you are using Google or Meta or Apple products, you feel like you have an integrated solution, you have one account, and then you have all these apps that are available to you and that interact well one with another. So that's what we want to do. But of course, we want also to give you freedom to develop new apps without being integrated with us. So we have already the React and the Svelte bindings for the data. We are talking about the client, right? The apps, the front end framework. You can bind your components to the data. And we'll add the Vue.js after. And we also have the APIs for TypeScript and Rust, because it's all developed in Rust and with WASM, then compiled to WASM. Later we will add those. We already have the Python bindings because everybody asked for it because of LLMs and AI. And then, but the rest we'll try to add it also. And now what? We have an app already, which is like a user-facing app that you install on your mobile and desktop and also for web. And this app is, some people call it the wallet app or the official app. I don't know exactly how to call it. But that's where you create your account, and then you have access to all your data in this app. And the app is local, right? It's local first. You have the data in your app. And then the other apps, the third-party apps, they connect to this app to get the data. Also, the data is encrypted at rest in this app. So not only it's encrypted in transit with end-to-end encryption, but it's also encrypted again when it is stored, because we cannot trust the Android or iOS or Ubuntu or whatever if you have encryption in your disk or not. So the wallet, it's to grant permissions to other apps, because the other apps that come to ask permissions, you're not going to give them access to all your data. You will say only to this, to that. You will be able to select which data you share with. You can search also all your data, and you can share with others and other users. And then inside this app, the data is organized into 3 main stores. One is the public, the other protected, and then the private store. So the private store is data that's only for you. It syncs between your devices, but that's all. Then you have the protected store for sharing data with other users, and you give them permissions. And then the public store is for public data accessible anonymously by anyone. And then you can create other stores for groups. You share data with a group, you put members in the groups, and that's it. Then we also have the idea of creating a social network with that, because as you will see, you have contacts, and we want to have a timeline and share posts and everything like that, but with end-to-end encryption. So it's different from AT-Proto or ActivityPub, which is all in the public. Here, it's with end-to-end encryption at heart. So it's more private social network and more decentralized also. We will see that about decentralization, what we are doing. And the suite of productive tools, as I said before, like to compete with the existing ones. This maybe you already saw it, right? It's about the difference between the client-server paradigm and the local first. You don't fetch data, you sync it. You subscribe to the data you want to sync, but it synchronizes in the background. You don't need to deal with that, the network and things like that. So it's a lot of the programming is in the front end, is in the client side. All the APIs also are there. You never call to a remote server or anything like that. We also focus a lot on zero single point of failures. So we removed the domain names. We still have servers, but we call them brokers. And they work only with an IP. You just need to run them behind a public IP. So it removes a lot of hassle with domain names. That's a good point, I think. And then, so peer-to-peer, yes, but not too decentralized neither. That's why I said we still have servers, because if you make a 100% peer-to-peer, it means that my device, my phone, my laptop is connecting to your phone, to your laptop directly with WebRTC or something like that. This is not something we want to do here, because we have a problem of asynchronicity. When you want to sync directly with another device, the other device has to be online at the same time like you. So that doesn't work in practice. So for this reason, we have these brokers in the middle that are servers that are running all the time, but they are end-to-end encrypted, so they don't see the data. They just store and forward the encrypted blocks. So it's good, it makes availability. It's good for availability and for privacy. This two-tier network, that's what it means. You have the first tier is the devices, and then the second tier is the brokers. So that's how it looks eventually. When it will work, it will look like that. The red points is the end users, devices, and the others, the blacks are the brokers. So this I said, and you can have backups and failovers because you have you can set up several brokers, and then your data is replicated into 1, 2, 3 brokers, and you can choose one or the other depending if they are online or not, if there is a failure. So then the protocol itself, it's based on the URIs are based on DIDs, if you heard of that maybe, DIDs. So it's a scheme, a special scheme for URIs. It doesn't start with HTTP or mail, or it starts with DID. And then many numbers and characters that represents the unique identifiers of profiles of your users and the users and the documents. Every document also has a unique identifier like that never changes. Even if you change the data, the ID doesn't change, of course. So that brings data portability and durability. It means that no matter where the data really is stored, on which server, which broker, I mean, or in which devices it is synced, the ID is the same, right? While when you use domain names with whatever, you don't have portability, because if you want to switch your account to another domain, then what do you do with the links, with the URLs, right? They change, they break. Here we have the cryptographic capabilities. This is what we use for sharing the data. So it means it's a link, but it's a long link. It's a DID URI, which contains the keys for encryption, decryption, and things like that. If you don't have these keys, if you don't have the full link, you cannot open the data. You cannot access it. It's encrypted. So we have compatibility with HTTP, of course. If you need to, you can run services, for example, in Node, as I said before, and then put that behind whatever you want, a REST API, headless CMS, and we have a web app, and it's working on the web also, everything we do. We are compatible with ActivityPub and Solid because we're collaborating with another project which is called ActivityPods, which is going to do that. Solid, why? Maybe some of you know about Solid. It's a project, an old project that is also based on RDF and semantic web. So now I think RDF, the good thing of RDF, which you can criticize a lot, but the good thing is it's good for interoperability. We will see how RDF is helping us with that in a moment. And all of that are synonyms. So RDF, it's the same as semantic web, link data, or web of data, if you heard any of those. That's what it looks like generally. It's like you have data and you link it together. So you have the predicates, we call them here, which are the relationships between different nodes, which are the nodes of the data. And of course, each node has properties. You can say this is its name, its birth date, where he was born, and things like that. This for people, but also for things, objects. So I believe that RDF can be used as a database. It's a database, a graph database. And for that, we refer to those databases as triple stores or quad stores, if you ever heard of that. That store any data in this form, the subject, predicate, object. It's triple for this reason, because it has 3 components. So if you want to map that in your head to JSON, That would be the name of the document, the JSON document. That would be the property, and that would be the value. The object would be the value that key value is here. Key value is the object. But then it's more than that, because the object can be a link to another document. So then you can link like that documents between each other, and each link, so in the subject and in the object, they are in fact these URIs that I was talking about before. So the full URI of your document goes here, or it goes there as the object if you're going to link to another one. That's very powerful because it's a global database, right? It's a database that you can store data that refers to any data on the web. So far they were using HTTP, but with NextGraph, the URIs becomes with deeds that are resolved to actual data. So then you have Sparkle. Sparkle is the query language for RDF. It's very powerful. It's more or less like SQL. And GraphQL could be added on top of Sparkle. Maybe you know more GraphQL or Cypher if you worked with Neo4j, for example. So I think Sparkle is more powerful even than Cypher, and it's also more standard. It's a W3C standard. Then in NextGraph, so we have Sparkle in NextGraph. It means you have Sparkle in your local application, in the client. You have a Sparkle engine there. That brings you revision history. You can revert. You have signatures on each commit on each operation. And so you can enforce authenticity, integrity, audit, and even time travel. It means you can query the data as it was in the past. That's things we are working on now, smart contracts, ACID transactions. GNU-Taler, it's a payment system, decentralized payment system. That's things that we don't have yet, but we want to have in the future. And blind queries, this is like a homomorphic encryption. It's like you can query the data while it is still encrypted, which is not the case for now. What we will do today, it's encrypted end-to-end, the exchange of data, but then when you query locally. The data is decrypted and queried after that. Okay, so that's the SDK. You can build social apps, data-centric apps, collaborative apps, anything you want. Now, let's start with today's feature, which is about social queries. I don't know if you have read the description of this session. While I'm going to explain it again, you can scan this. It's giving you the repo that you need to clone and start to npm install and everything. So the idea is that LinkedIn, for example, we take the example of LinkedIn or any app social app that we are using, you know how they work. Big tech, they have big cloud and data centers, and so the programmers of these apps, they enjoy a database that is global. They have access to all the data of all their users, so it's easy for them to make queries in the graph and find recommendations. You know, they recommend you people that you might know, topics that you might know, content that you might like, and things like that. For that, you need a graph database. They all have graph databases behind. But they have this global database, right? When we do decentralized systems, local first, decentralized, whatever you do, peer-to-peer, you don't have this database. Nobody has it, right? Nobody has this big global data. So we need to find other ways to still query the social graph and the data, not only your data, but also the data of the others. So that's what I call social queries. Social queries is a mechanism to go and ask to the people that you have as a contact for some Sparkle queries. They will run it locally, return you the results, and they will also spread these queries to the others. Why? Because here you see in the logic of all your application can only be in the client when it's end-to-end encrypted or local first or whatever. We have the broker 1, the broker 2, like I said before, the brokers, right? And you have the clients, the apps. Those in green, they do have access to the plain text and to the materialized state. For CRDTs, we are talking about materialized state. It means I take all the operations and I reconstruct the data locally. But the brokers, they have nothing. They just see encrypted commits. They can do nothing with it, right? All the red things. one. So the broker, the server with encrypted data, cannot read data, cannot run queries, cannot run services. The device can. It can do all three, but it cannot run global queries. That was I was just saying. So we have a mechanism called an inbox, which is in the broker. The client registers to the inbox. It's a public key, and says, I have the private key. He shows that with the signature, has the private key for this inbox, and it tells to the broker, keep me messages for this inbox. Now, another one comes and says he has the public key, the address of the inbox, and says, I give a message, an encrypted message to this inbox, and the broker will keep it. This message, of course, it's encrypted to the public key of the inbox. So it stores it. Now the app is online again, this one, let's say, and has the key. He's the owner of the inbox, so he will fetch the message and decrypt it. It's an asynchronous mechanism to pass messages or any kind of data between the two. It's different from the CRDTs that I was explaining before. The CRDTs work differently. They are, I'm not going to talk about that today, but they have a sync protocol that is slightly different. Here, it's a mechanism of inbox. It passes messages end-to-end encrypted to the recipient. We can reply to them, because also when we send a message here, this one will give the public ID, the ID of his inbox, so we can reply. And then I use that for DMs, sharing documents between users, comments and backlinks, and form submissions and social queries, which is what we will do today. So what is a social query? I already said it, but here is a small recap. Me, my account, my profile, and then I send the query to my contacts, then they send it to their contacts, and they send it also to a third level. The level can be configured in the query. You can say 2, 3, or infinite, and so on. And of course, here there is, in one corner, you will see that there is one yellow that receives 2 requests. It receives this one to the right in the middle. It receives a request from 2 red ones. And that's, of course, we deal with it. Here, when we get the answers, the replies, he won't send a reply twice about the same query. So to avoid cycles in the network. So this mechanism has several interesting properties. The first one is web of trust and integrity. It means that when I'm sending a query to my contacts, so between the green and the blue, the contact answers to me first what he has locally. And I can verify that because I know who this contact is, because he's in my contact list. So if I verify his data, their data, because I know them, I can verify their data, and I know that the data is trustworthy. But then this blue contact will also do the same with the red contact, their contact, and do the same kind of verification and send me back these things. So because I trust the blue and the blue trusts the red, I transitively trust the red, right? And so on. That's how it works. So the degree of how far it goes is configurable, as I said. Privacy, it's very private because also we try to anonymize everything. So between me and my peers here, I know their identity because I know them. I send them the query, but all the results that will come from far, the identity of the people is removed on the way. So I don't know who it comes from. It has been verified by the blue. The red has been verified by the blue, but the blue, when he sends to me back, he removes the identities. I can only see raw data. That's important also, so that I can feel good to participate in this social query. I don't reveal a lot of information. Then it prevents the cycles, I said it. Asynchronous, it means that it works offline, online, offline, intermittent connections. The only thing I need to do is to send it to my inbox, then it will come back to me later, even if I wasn't online for a while, the query still goes on in the social network, and then it will come back. It's not always the same peer or replica that will answer. You might have started the query with your phone, and then you will continue the query with your laptop or another device. It still works. because it's local first, we synchronize everything between devices. So what's the app? The app is about that. Rate our context skills, right? So skills, it's about here, this is what we'll do. We'll do it quickly, as you see, because I'm talking a lot. The skills of programming, query with Sparkle for matching the contacts. It means when the query is about, I'm writing the query in Sparkle and I'm asking, do you have contacts that have 2 skills and 3 optional skills? You will see in the query. Out of all these skills. That's the query I did, but we could make it configurable. And then I receive the results, and I aggregate locally all the results and rank. I rank, so it's a standalone app, because we also can develop apps inside the app of NextGraph, but here it's the standalone app. Sorry, Safari doesn't work. I hope you have Chrome or Firefox. It doesn't work yet, Safari. I'm still working on it because I'm using third-party cookies. So also you need to allow third-party cookies. So let's create a wallet on your phone, if you have a phone. It's going to be easier for the sharing contacts on nextgraph.eu. You have to create a wallet. So the wallet, it's what keeps your data. It's encrypted also, and it's it's kind of a lengthy process, but you need to, for security reasons, to select a picture that will be the picture of your wallet, and a small sentence also, like a few words you put to identify your wallet. It's not the name of your profile or your account. And then you will be given 12 a mnemonic, it's called, 12 random words that are your password. And you need to keep these 12 words somewhere in your, on the side, because you will need it later to log in. There is another way to log into your wallet, which is the puzzle. This is something you can try later that I developed, but nobody's using it because it's too complicated. I find it cool because it's a way to, you don't need to remember a password or 12 words. You need to remember 9 images, but okay, it takes maybe some time to learn them. Because what you will do when you will start to use that, you will put these 12 words in a password manager, right? That's what everybody does. But I want NextGraph to be the password manager. So it's like a chicken and egg. It's like, where do you put eventually your master key or master secret? I would prefer you to, anyway. And we will add also a password, just username and password later on for those who want that. So everybody has created a wallet. We'll make a social network now. So I hope you are close to each other for those who want to participate in the experiment, because you'll have to scan a QR code. So let's add some contacts. So you need to go to this login profile, to this public profile, sorry. And then you click on the 3 buttons here. You see the 3 hamburger buttons? And then view as QR code. You already have, so I will scan you. Super. So I add a contact.
I'm not sure if I did it correctly.
Yes, and now you should have me as a contact too. Hmm? Ah, Yusuf, super, great. I will add you as a contact. You don't need to do it all with me. You can also do it between each other. It's better even for the demonstration. It will really show that it's decentralized. Otherwise, you will think I'm the single point of failure. So here, QR code. Okay, so I have 2 contacts, it's enough. So now we have this. So I will continue because I need to move on. I have 2 contacts. If you want to add someone, you need to go to create and then social contact and then import with QR code. Okay, so now we can go back to the demo. That's the demo. That's the. No, it's reverse. Yeah. Super. Great. Thank you, Kevin. So now we can go back to the demo, to the code. What do we have here? It's npm install, npm run build LDO, npm run dev if somebody wants to run the app locally, the app that we're going to develop in a few minutes. Okay, you need to import your wallet from your phone to your laptop. If you already have it in the laptop, it's easier. You don't need to, you can skip this part. Okay, so now you can, do you run the app in localhost? Did you run, yes? So if you go to this app, it's localhost 5174. If you're running it in npm run dev, it should show you a screen to log in. So you need to log in with your wallet. And then you should be all set with a white window. Okay, so I developed this app with Vite, React, and Tailwind. You can see that in the package.js. That's the wireframe of the app. It's, we have the LDO provider. This is for authentication. Then we have the header, which is going to show you if you are not authenticated that you need to authenticate. And if not, it's going to show you the rest, which is composed of two routes. One is to create contacts or see your contacts. And then the second route is to query, to make the social query. So for the data itself, I can show you already. Where is it? Here. So that's the schema of the data. The data is here, Sparkle RDF. Sorry. So we have the data is the schema is expressed here with a shape in the format is called checks. And I'm basically saying here that I can take in as a contact, right? What is a contact? It can be of the class individual person or there are two types of persons. That's the class, that's the type of the data, and then it has three properties. One is vcard fn, which is the full name. It's going to be your full name. Then there is the email address. And then there is, this one is like, it's a list of skills. And then I detail, it's a sub-object, like it's inside. I detail what is this object here for each skill. It's defined like this. It also has properties. One is rated, so it's 0 base 0 to 4. And then which skill I'm rating. So I have made the choice here. It's an enum. It's I have 7 or something, 8 skills here. That's the schema. And from this schema, I run the command that I talked about before, this command here, npm run build LDO, and it will generate sometimes TypeScript definitions for that object. And I have a binding now to my RDF, to my triples, my database. That's it, sorry. So it has bindings for React and Svelte, and that's I already said. And this we already saw it. That's it. So now I'm going to add the components. The components, there are 3. So you can copy-paste it also like me, taking it from Demo Berlin Final, which is the same project, but it has the code already. Let's do it. Contact. So contact is here. It was just empty at the beginning. Now I will go over it. What does it do, contact? It's to edit a contact. We'll see that later. No, yeah, we can see it already. Where is it, the code, the HTML? So here, you see the binding. You have here contact.fn, super easy, it's the name of the property. Contact.has email, it's going to display the email. This for each contact. And then I have the list of skills. And then I display with stars, you know, if they are, how much they are rated. Then I have contacts with an S, which is just the list. It's showing the list of, this is just simple React, just showing me the list. And it also has an additional thing to add a contact. We will not use that for now, so I'm not even going to put it. And then we have the query. So the query is the other page, the other route, which is about how to generate the query itself. And let's have a look at this. Is this is the main thing, right? I have a few minutes to show you. So it's here. Where is it? Sorry. Here. I start. So if I click Start, Open Query. If I click the button Open Query, what does it do? It's going to create a document in NextGraph of the type social query to store the information about this query. So first it will store the Sparkle query that needs to be run everywhere in the social network. And then I will send it. So here the Sparkle query itself is defined, it's a string, it's defined above. It's here is this query. So it's a bit, looks a bit intimidating, but it's like SQL. I select what I want. Here I said I select two skills must be present, Rust and Svelte. So please, if you rate others, rate them with Rust and Svelte, otherwise it's not showing in the results. This is the query I did as a demo. And then I asked for four additional here. So these are the two mandatory ones. And here is the filter for the optional ones. And it will return me some triples about that. And then those triples are going to come and be aggregated in the original document that I have created at the beginning. I created a document here. I put a query in it. And when the results will come, they will all come aggregated inside this document. That's how the social query API works. And every time I get new data, because it's asynchronous, it will, over time, it will come several times like that, as big as your social network is. Every time there is something new, I'm called back, and this is where it's interesting. Where is it? Here, use effect. So I say every time there is something that changed here, I want to be called back. Where is that? Okay, rate. No, this is about rating, sorry. This is not this part. This is how do I rate, how do I edit the ratings? Get resource, sorry. Commit data. Okay, get resource, change data. Okay, so now we can test it. I will explain more about the code if I have a few minutes, but maybe you want to test it? No, it's finished?
Yeah, like 570.
Okay, so I end here. We didn't test it, but we can test it later on for those who have the app installed. Sorry about that. If you have questions, you can also ask me privately on the site. Thank you very much.